Hey there, friends. It's time for another mind-blowing episode of Why Facts. Today, we're uncovering something you've likely noticed your whole life, but maybe never questioned deeply. Why does ice float on water? Now take a moment and think about it. Doesn't it seem kind of strange? Most solid materials are denser than their liquid form and naturally sink, right? But not ice. Ice rebels. It defies this expectation. It floats. And today we're going to unravel how and why this fascinating exception occurs with the help of science. Buckle up, because by the end of this video, you'll look at your favorite chilled beverages in a whole different light. So, let's dive in. To understand why ice floats, we have to start by looking under a microscope, figuratively speaking, of course, at the water molecule, the very foundation of this mystery. The chemical structure of water is pretty simple. Two hydrogen atoms bonded to one oxygen atom, forming that iconic H2O molecule. But don't let its simplicity fool you. There's a whole world of complexity hidden in this tiny molecule. Water molecules have an intrinsic property known as polarity. The oxygen atom in the molecule is slightly negative, while the hydrogen atoms are slightly positive. This configuration makes each water molecule act like a mini magnet, with opposite charges attracting and like charges repelling. Keep this idea in your pocket for now because it's key to understanding everything else. Now, as water gets colder, its behavior starts to get quirky. Water is one of the very few substances on Earth that expands as it freezes. Most other substances contract into a denser, more compact structure when they solidify. But water? It does the opposite. Imagine filling a balloon with water and then freezing it. Instead of shrinking, it would expand and possibly even burst. Why? It all comes down to hydrogen bonds, a characteristic interaction between water molecules. When water cools and approaches its freezing point, around 32 degrees or 0 degrees, its molecules start slowing down. As they slow, they have the opportunity to form more stable and rigid hydrogen bonds. These bonds arrange themselves into a unique crystal lattice that we know as ice. And here's the kicker: this lattice structure is surprisingly spacious. By locking the molecules into a rigid and organized pattern, ice ends up occupying more volume than the liquid water it came from, despite containing the same number of water molecules. So, what does this mean for density? Density, as you might recall from science class, is all about how much stuff fits into a given space, or more precisely, mass divided by volume. Because the ice crystal lattice takes up more space but doesn't add more mass, it becomes less dense than its liquid counterpart, and anything less dense than water will naturally float atop it. A practical example. Think back to that glass of iced tea you might have enjoyed during summer. Those ice cubes floating at the top of your glass are essentially doing so because of this unique hydrogen bonding phenomenon. Without that scientific quirk, all your ice would sink to the bottom of the glass. Imagine what a disappointing glass of iced tea that would be. Now, you might be wondering if this quirky property is just some kind of fun party trick for your beverages. Far from it. The fact that ice floats on water has profound implications for life as we know it. In fact, this seemingly simple property is critical for the survival of ecosystems, especially in cold climates. Consider a lake during winter. As temperatures drop, the surface water begins to freeze, forming ice. Because ice is less dense, it floats on the surface, creating a sort of insulating blanket above the liquid water beneath. This layer of floating ice prevents the water below from freezing solid, even in extremely cold environments. As a result, fish and other aquatic life can continue to live in the liquid water underneath the ice during winter months. It's a great example of nature's clever design, don't you think? But hold on, there's more. Scientists believe that if water didn't behave this way, if ice sank instead of floating, entire ecosystems would collapse. Lakes and oceans would likely freeze from the bottom up during cold weather, with devastating consequences for aquatic life. Ice floating thus ensures that life can persist, even in harsh, frozen climates. But let's zoom out and think globally. Ice caps and glaciers, large-scale floating masses of ice, play a significant role in regulating the Earth's climate. They reflect sunlight back into space, helping to regulate global temperatures through something called the albedo effect. If ice sank, much of it wouldn't form where it currently does, leading to drastically different conditions on Earth, and possibly rendering large portions of the planet inhospitable for life. All of this is possible because, on a molecular level, water expands and becomes less dense when it freezes. Incredible, isn't it? And speaking of nature, did you know that this unique behavior of water likely contributes to our planet's geological history as well? During ice ages, expanding glaciers can carve out valleys and change landscapes in ways that wouldn't be possible if ice behaved like most other substances. How mind-blowing is that? So let's recap. Ice floats because its molecules form a highly ordered, expansive crystal lattice as they freeze, making it less dense than liquid water. This property is not only interesting but essential for life, affecting everything from the taste of your favorite iced drink to the survival of fish under frozen lakes to the stability of our planet's climate. Isn't it amazing how a single property of a tiny molecule can have such far-reaching consequences? By now, you might be asking, is water truly unique? Or do other substances also behave in this curious way? Well, water is indeed one of the rare exceptions. Very few other materials expand when they freeze. Silicon and bismuth are two rare examples, but they don't have the same life-giving properties that water does. And let's not forget the quirks water pulls off even before freezing. Water actually reaches its maximum density at about 4 degrees, 39 degrees, just above freezing. This means that as water cools from room temperature, it becomes denser until it hits that magic number. Then, as it cools further and starts freezing, it does a complete U-turn and begins to expand again. Fascinating, isn't it? Remember, next time you toss a few ice cubes into your drink or admire the serenity of a frozen lake, you're witnessing one of nature's most subtle yet profound phenomena. Behind the simplicity of ice and water lies deep, complex science that has far-reaching implications for life on Earth. So next time someone asks you why ice floats, you can not only tell them the answer, but also blow their minds with how intertwined this simple fact is with the thriving life here on Earth. And there you have it, folks, the science behind why ice floats on water. It's not just a neat party trick or a handy trait for your summer drinks. It's a property that is fundamental to the existence of life as we know it. Isn't science just awesome? Thanks for joining us in this episode of Why Facts. If you found this as fascinating as we did, don't forget to smash that like button, share this video with your friends, and hit subscribe for more incredible science stories. Until next time, keep asking why, because curiosity leads to amazing discoveries. Thanks, and bye for now.